Welcome to my channel. In this video, you're going to learn how to solve simultaneous equations using different methods. So I have listed several methods that we're going to use to solve simultaneous equations. The first one that we have is the matrix method. So the first example, solve the following simultaneous equations using matrices. So the part A, we have 2x plus y is equal to 1. 10x plus 3y is equal to 17. So the first thing we need to do is to rewrite these in a matrix form, where you have the first matrix as the matrix of the coefficients of these variables. So you have 2, 1, 10, and 3. Then the second matrix is the matrix of the variables, that is x and y. And then we have the matrix of the results, that is 1 and 17. So you can name them as A, X, and B. So it's like you have A times X is equal to B. But remember, you are trying to look for X and Y. So the unknown is X. So you can obtain the unknown as the inverse of A times B. Because you divide both sides by A, it will be B over A, which can be rewritten as A raised to power negative 1 times B. So this implies that we have to obtain the inverse of the matrix A, that is 2, 1, 10, 3. So for us to be able to obtain the inverse, we first of all need the determinant of A, which can be obtained by multiplying the members of the main diagonal, that is 2 times 3, minus the product of the members of the other diagonal, that is 1 times 10. So that will be 6 minus 10. So 6 minus 10 is the same as negative 4. And then the next thing that we need is the adjoint of A. So the adjoint of A is just switching the members of the main diagonal, that is 2 and 3, so that we have 3 and 2, and changing the signs of the other diagonals. So that will be negative 10 and negative 1. So that is the adjoint of A. So therefore it means that the inverse will be 1 over the determinant, which is negative 4, times the matrix or the adjoint, which is 3, negative 1, negative 10, 2. So now that we have the inverse, we can obtain the unknowns, that is x. And remember, x was x, y, and we say that it could be obtained by multiplying the inverse of A, which we have as 1 over negative 4 times 3, 1, 3, negative 1, negative 10, 2, times B, and B is 1, 17. So we can multiply these two matrices, that is 1 over negative 4 into 3 times 1 plus negative 1 times 17. Then we have negative 10 times 1 plus 2 times 17. So we can simplify that so that we have the matrix as, this is 3 times 1, which is 3, minus 17. Then we have negative 10 plus 34, which can be simplified to be negative 1 over 4. This is the same as negative 14. And this is the same as positive 24. So that we can have this as negative 1 over 4 times negative 14, and the second one will be negative 1 over 4 times 24. So if you simplify this, you're going to get this to be 7 over 2, and the second one will be negative 6. And remember, that was the same as x, y. So this means that x is equal to 7 over 2, and y is equal to negative 6. Part B, you have a plus b is equal to 7 and a minus b is equal to 5. So the first thing you need to do is just form three matrices, where the first matrix is that of the coefficients of the variables. So we have 1, 1, 1 and negative 1 times the second matrix, which is just the matrix of the variables a and b, and the third matrix is that of the results, that is 7, 5. The next step is just to label them a, x and b. So you have a, x is equal to b, which means that x, which is the unknown that you're looking for, is the same as b over a, which can be written as the inverse of a times b. So it means therefore that we have to look for the inverse of a, and for us to get the inverse of a, we first of all need the determinant of a, which can be obtained by taking the product of the main diagonal, that is 1 times negative 1, minus the product of the other diagonal, that is 1 times 1. So we have negative 1 minus 1, which is just negative 2. So that is the determinant of this particular matrix. So the next thing for us to get the inverse is to obtain the adjoint of a. So the adjoint of a is obtained by just switching the members of the main diagonal. So we'll have negative 1 and 1, and changing the signs of the members of the other diagonal. So that is negative 1 and negative 1. So now that we have the determinant and the adjoint, we can easily obtain the inverse of a as 1 over the determinant, which is negative 2, times the adjoint of a, which is negative 1, negative 1, negative 1, 1. So now that we have the inverse, we can obtain the value of the unknown using the expression that we had. We said that for you to get the unknown, that is x, you will need the inverse of a times b. So the unknown, which is x, is given as a, b, and we can obtain that by taking the inverse of a, which is 1 over negative 2, times the matrix, which is negative 1, negative 1, negative 1, 1, times b, and b is 7, 5. So we have 1 over negative 2 into, so we can multiply these two matrices. So we have negative 1 times 5 plus negative 1. Now this is negative 1 times 7 plus negative 1 times 5. Then the next one we have negative 1 times 7 plus 1 times 5. So you can simplify the bracket. So we have 1 over negative 2. This is negative 1 times 7, which is negative 7, minus 5, then minus 7 plus 5. We can simplify this further so that we have negative half into minus 12, and down here we have minus 2. So we can multiply that matrix by the scalar so that we have negative half times negative 12, and you have negative half times negative 2. So if we simplify this, we're going to get 6, and here we're going to get 1. And remember, this was a and b, a, b. So this implies therefore that a is equal to 6 and b is equal to 1. Part C, 3x plus 4y is equal to 18, and 5x plus 6y is equal to 28. So the first thing you need to do is just form three matrices using these two equations. So the first matrix will be that of the coefficients of the unknowns. So you'll have 3, 4, 5, 6, and the second matrix is that of the variables x and y. The third matrix is that of the results, that is 18 and 28. And for you to get x, you just have the inverse of A times B. So let us get the inverse of A, and for us to do that, we have to get the determinant of A, which is obtained by taking the difference between the product of the main diagonal and that of the other diagonal. So we're going to have 3 times 6 minus 4 times 5. So that is 18 minus 20, which is the same as negative 2. Then the next thing we need to obtain is the adjoint of A. So the adjoint is just switching the main diagonal and changing the signs of the other diagonal. So it means we'll have 6, we'll have negative 4, we'll have negative 5, and 3. So if that is the case, we can now obtain the inverse of A by taking 1 over the determinant. Our determinant is negative 2 into 6 minus 4 minus 5, 3. So that is the inverse of A. So we can use that inverse and B to obtain the value of X. So we say that X, which is XY, is given by taking the inverse of A, which we have found to be negative 1 over 2 into that particular matrix, that is 1 over negative 2 into 6, negative 4, negative 5, 3, times B, and B is 18, 28. So we can simplify these matrices. We can multiply the two. So we have 6 times 18 plus negative 4 times 28, and then here we have negative 5 times 18 plus 3 times 28. So we can simplify that further. 6 times 18 is the same as 108, and negative 4 times 28 is the same as negative 112, and then we have negative 5 times 18, which is negative 90, plus 3 times 28, which is 84. So we simplify that further. So 108 minus 112 is the same as negative 4, and minus 90 plus 84 is the same as negative 6. So you can now multiply this matrix by this color. So we have negative half times negative 4 and negative half times negative 6. And remember, it is a matrix still. So this, the first part will be 2 and the second part will be 3. And remember, this was xy. So this implies that x is the same as 2 and y is equal to 3. Part D, 2m plus n is equal to 7 and 3m minus 2n is equal to 10. So the first thing is just to write these in form of matrices, where the first matrix is that of the coefficients, which is 2, 1, 3, negative 2. And the second matrix is that of the variables m and n. And the third matrix is that of the results, that is 7 and 10. The next is just to label them as A, X, and B. And for you to get X, just take the inverse of A times B. So you just need to get the inverse of A, and for you to do that, you need the determinant of A, which is obtained by taking the difference between the product on the main diagonals, that is 2 times negative 2 minus 1 times 3. So here you have negative 4 minus 3, so that the determinant is negative 7. The next thing is just to obtain the adjoint of A, which is obtained by switching the main diagonal and changing the signs of the other diagonal. So we'll have negative 2, negative 1, negative 3, and 2. So from there we can obtain the inverse of A by multiplying the 2. So we have 1 over negative 7 times negative 2, negative 1, negative 3, 2. So that is the inverse of A. So now that we have the inverse of A, we can obtain the value of the unknown, that is x. And x, remember, was mn. So for us to obtain that matrix mn, we take the inverse of A, which is 1 over negative 7, negative 2, negative 1, negative 3, 2. And then we multiply that by b, and b is 7, 10. So we can simplify the matrix by multiplying them. So we have negative 2 times 7 plus negative 1 times 10. Then you have negative 3 times 7 plus 2 times 10. So if we simplify this, we're going to have negative 1 over 7. Then in the first case, we have negative 2 times 7, which is the same as negative 14. So we have negative 14 plus negative 10, that is minus 10. Then here we have negative 21 plus 20. So if you simplify this further, you're going to have negative 24 and negative 1. So now we multiply by the scalar, so that we have negative 1 over 7 times negative 24, and here we have negative 1 over 7 times negative 1. So if we simplify that, we're going to have, this is the same as 24 over 7, and this is the same as 1 over 7. And remember, these were m and n. So this means that our m is the same as 24 over 7, and our n is the same as 1 over 7. Number 2, solve the following simultaneous equations using elimination method. So part A, we have 9x minus y plus 7 is equal to 0, and 13x minus 4y plus 5 is equal to 0. So the first thing is just to rewrite them in the standard form, so that we have all the unknowns on the left hand side and the constant terms to the right hand side. So we'll have 9x minus y is equal to minus 7, and 13x minus 4y is equal to minus 5. So the next thing is to eliminate each unknown one at a time. So the first instance, we'll say, let's eliminate x. So for us to be able to eliminate x, we must make sure that the coefficients of x are the same for the two equations. So we have 9x minus y is equal to minus 7, and we have 13x minus 4y is equal to negative 5. So for us to make sure that the coefficients of x are the same, we just cross multiply. We multiply the first equation by the coefficient of x in the second equation. So the first equation will be times 13, and then we multiply the second equation by the coefficient of x in the first equation. So we multiply that by 9. So if we do that, you're going to get 9x times 13 is the same as 117x minus 13y is equal to negative 91. Then for the second equation, we have 13 times 9, which is 117x, minus 9 times 4, which is 36y, is equal to 9 times negative 5, which is minus 45. So now that the coefficients of x are the same, we can eliminate x by subtracting the two equations. So you'll have 0 plus, if you minus these two, you're going to get positive 23y is equal to, if you minus these two, you're going to get negative 46. So you have that 23y is equal to negative 46, meaning y is equal to negative 46 over 23. So that y is equal to negative 2. So now that you have eliminated x, you can now solve for x by eliminating y. So let us eliminate y. So for us to be able to eliminate y, we have to make sure that the coefficients of y for both equations is the same. So the equation that we have is 9x minus y is equal to -7, and 13x minus 4y is equal to -5. So for us to make sure that the coefficients of y is the same for both equations, we just cross multiply by their coefficients. So it means we multiply the first equation by the coefficient of y in the second equation, that is -4. But we can just take 4 and then we multiply the second equation by 1. So if we do that, we're going to end up with a different equation, that is 4 times 9, that is 36x minus 4y is equal to -28. And then the second equation will remain the way it is, that is 13x minus 4y is equal to -5. So now that the coefficients of y are the same, we can eliminate y by subtracting the two equations. So we're going to have 36 minus 13, which will be 23x, plus minus 4y minus 4y is the same as minus 4y plus 4y, which is 0, is equal to minus 28 minus 5 is the same as minus 23. So it means we have 23x is equal to -23. So that x is the same as -23 over 23. So that x is the same as -1. So therefore we have that x is equal to -1 and y is equal to -2. Part B, 3x plus 4y is equal to 6 and 4x minus 6y is equal to 11. So we can first of all eliminate x. So for us to be able to eliminate x, we have to make sure that the coefficient of x is the same for both equations. So all we have is 3x plus 4y is equal to 6 and 4x minus 6y is equal to 11. So for us to make the two coefficients the same, we cross multiply by those coefficients that are there. So it means we'll multiply the first equation by 4 and then multiply the second equation by 3. So if we do that, we get this to be 12x plus 16y is equal to 24, and the second equation is 12x minus 18y is equal to 33. So we can eliminate x by subtracting the two equations. So if we subtract, we're going to have 0 plus 16y minus -18y, that is the same as positive 34y is equal to 24 minus 33, which is -9. So therefore we have 34y is equal to -9, so that y is the same as -9 over 34. Then now we can eliminate y to get x. So let us eliminate y. So we have the equation 3x plus 4y is equal to 6 and 4x minus 6y is equal to 11. So for us to be able to eliminate y, we'll have to make the coefficients of y the same for the two equations. So we can do that by cross multiplying by the coefficients of y that we have. So we'll multiply the first equation by 6 and the second equation by 4. So if we do that, we get a new matrix, which is 18x plus 24y is equal to 36, and then we also do the same for the second one, so that we have 16x minus 24y is equal to 44. So these coefficients are the same, and we can eliminate them by adding the two matrices, the two equations. So we'll have 18 plus 16, which will be the same as 34x plus 24 plus negative 24, that is 0, is equal to 36, plus 44 is equal to 80. So we have 34x is equal to 80, so that x is equal to 80 over 34, which you can simplify to be 40 over 17. So it means therefore that x is equal to 40 over 17 and y is equal to negative 9 over 34. Part C, m plus n is equal to 8 and m minus n is equal to 4. So we can first of all eliminate m. So we have m plus n is equal to 8 and m minus n is equal to 4. So we can eliminate m by subtracting. So we have 0 plus n minus n, that is plus n. So we have 2n is equal to 8 minus 4, that is 4. So we have 2n is equal to 4, so that n is equal to 4 over 2, so that n is equal to 2. We can do the same for n. So let us eliminate n so that we are able to obtain m. So we have m plus n is equal to 8 and m minus n is equal to 4. So we can eliminate n by adding. So we'll have 2m plus n plus negative n is 0. Then we have 12. So it means 2m is equal to 12. So that m is equal to 12 over 2. So that m is the same as 6. So therefore we have that n is equal to 2 and m is equal to 6. Part D, a plus b minus 12 is equal to 0. 2a plus b minus 6 is equal to 0. So the first thing, we just rewrite it such that the constant terms are on the right hand side. So we'll have a plus b is equal to 12 and 2a plus b is equal to 6. After that, we just eliminate each variable one at a time. So we're going to have, the first step is to eliminate a. So for us to be able to eliminate a, the coefficients of a for both equations must be the same. So for us to be able to do that, we are going to multiply across. We are going to multiply the first equation by the coefficient of the second equation. So we multiply the first one by 2 and then the coefficient of the first equation, which is 1. So we're going to end up with 2a plus 2b is equal to 24, and this one is just 2a plus b is equal to 6. So you can eliminate a by subtracting, so that we have 0 plus b, 24 minus 6, that is 18. So we have that b is equal to 18, and then we can eliminate b to obtain a. So let us eliminate b. So we have a plus b is equal to 12, and we have 2a plus b is equal to 6. So we can get rid of b by subtracting the two equations. So we have a minus 2a, which is minus a, plus 0 is equal to 12 minus 6 is 6. So we have that negative a is equal to 6, so that a is equal to negative 6. So therefore a is equal to negative 6 and b is equal to 18. Number 3, Solve the following simultaneous equations using substitution method. So part A, we have 3x plus y is equal to 13, and we have x plus 2y is equal to 1. So in substitution method, all we need to do is to express one variable in terms of the other. So we can start by labeling these equations as 1 and 2, so that we can say that from 1, you can say that y is equal to 13 minus 3x, and then now substitute. You can substitute that into equation 2, so that wherever there is y, we write 13 minus 3x. So in the second equation, we'll have x plus 2 into y, that is 13 minus 3x is equal to 1. So x plus 26 minus 6x is equal to 1. Then we collect the like terms. We have x minus 6x is equal to 1 minus 26. So that we have negative 5x is equal to negative 25. So it means x is equal to negative 25 over negative 5. So that x is just equal to 5. So we also expressed y to be 13 minus 3x. Y is equal to 13 minus 3x. And we have the value of x. So we just substitute. So 3 into x, which is just 5, is the same as 13 minus 15, which will give you negative 2. So therefore, we have that x is 5 and y is equal to negative 2. Part B, y is equal to negative 3x plus 2 and y is equal to 2x minus 8. So in this case, one variable has been expressed in terms of the other. So we can just equate the two because both of them are y. So we are allowed to say that negative 3x plus 2 is equal to 2x minus 8. And then we collect the like terms. So we have 3x minus 2x is equal to minus 8 minus 2. So on the left hand side, we have negative 5x is equal to, on the right hand side, we have negative 10. So it means therefore that x is equal to negative 10 over negative 5, so that x is equal to 2. Then we can take any of the two equations to find the value of y. So we can even take the first one, so that y is equal to negative 3x plus 2. So we have negative 3x into x, which is 2 plus 2. So this is negative 6 plus 2, which is negative 4. So therefore, we have that x is equal to 2 and y is equal to negative 4. Part C, 2y minus x is equal to 4 and 2x minus 3y is equal to 2. So we can just label them as equation 1 and equation 2. So we can express each of these particular variables in terms of the other. So we can say that from equation 1, we have that 2y is equal to 4 plus x, so that y is equal to 4 plus x over 2. So we can now substitute in to the second equation, so that wherever there is y, we replace that by 4 plus x over 2. So we'll have 2x minus 3y, and y is 4 plus x over 2 is equal to 2. So we just simplify this, so that we have 2x minus 3 times 4, that is 12, over 2 minus 3x over 2 is equal to 2. Then from there we just collect the like terms. We have 2x minus 3x over 2 is equal to 2 plus 12 over 2, which is 6. So we have the LCM as 2, so 1 into 2, 2 times 2 is x minus 3x is equal to 8. So that we have 4x minus 3x is equal to 2 times 8, that is 16. So we have 4x minus 3x, which is just x, is equal to 16. So we have the value of x. We can obtain the value of y by just substituting for the value of x there. So y is equal to 4 plus x over 2, which means that y is equal to 4 plus 16 over 2, which is the same as 20 over 2, which is just 10. So therefore we have that x is equal to 16 and y is equal to 10. Part D, x plus y is equal to 7 and 2x minus y is equal to 5. So you can label them as equation 1 and equation 2. Then we say that from equation 1 we can have that y is equal to 7 minus x. Then you can now substitute into equation 2. So whatever there is y, we put 7 minus x. So we have 2x minus y, that is minus 7 minus x, is equal to 5. So we open up the bracket so that we have that is equal to 5, and then we collect the like terms, is equal to 5 plus 7, so that we have 3x is equal to 12, so that x is equal to 12 over 3, so that x is equal to 4. And then we can get the value of y by using the expression that we had, that is y is equal to 7 minus x. So 7 minus 4, that is equal to 3. So therefore we have that x is equal to 4 and y is equal to 3. Thank you for watching. Kindly do not forget to subscribe, share and like.